for the exam. So the exam covers chapters 1 through 5, as noticed. So we've had all the quizzes. Everybody's had a first shot at the quiz, I think, and they've all been graded. So if you want to go look in there and take a second shot at it to raise your grade on it, that's totally cool. Looking at the quizzes, there are a few things that people missed a lot. And one of them may be something that I didn't reinforce in here. Maybe I only mentioned it once. I know it's in the book. But let's go ahead and talk about it. And let's see. Where did I get my notes? Alrighty. Actually, the one that got missed most was, what is a sentinel value? And the question was something like, you know, enter a value or -1 to quit. -1 to exit. And the question, the possible answers were, is it a break value? Is it a sentinel value? And then a couple other silly answers. Huge numbers of y'all chose break. I need to see if more than 50% did. On an exam, if more than 50% of y'all missed a question, then I'd probably count it as null, because then it meant that I didn't cover it adequately. Unless it was deliberately designed to be super hard, and I don't usually do that. So the answer is not break value, although it often is implemented with a break statement. It's what's known as a sentinel value. Sentinel value is a piece of data that means something different than the rest of the data being entered. Without a sentinel value, you wind up doing something like this. Please enter test score. You type it in. Do you wish to add another one? Yes, no. Please enter test score. Do you wish to add another one? Please enter test score. And if you can just do it, please enter test score or -1 to exit, then they just type in a number, hit enter, type in a number, hit enter, type in a number, hit enter, and then they hit -1. So they can do data entry twice as fast. So yes, it is implemented with a break. You know, if value is equal to, you know, -1, then break. So I see why y'all chose that. But it is a sentinel value. And I put that comment in everybody's quiz, so you'll see it anyways. Next one was summation loops. I'll go back to that. And then what does print end do? For one thing, I goofed. I forgot to put the comma in there. But if you pop open idle, let's just call it September 3rd. If you do something like this, print hello, and then you do print Bob, and then you run it, it's going to print hello on one line and Bob on the other. Like that. What if you wanted them both on the same line? Yeah, you can modify the print statement to be print hello, comma Bob. We could do that. But that would, put in quotes of course, but that won't always work, because what if you're printing out a series of values? But what you can do is you can specify another parameter. You can pass in another argument to the print function saying, I don't want you to go to the next line. Maybe I don't want you to do anything at all. Maybe I just want you to sit there. So when I ran this, it would say, hello, Bob. Yes, of course. Without any spaces. Well, maybe that's not what I want. Maybe I want a space in there. But you see what it did? I short-circuited the \n that it's automatically inserting between every call to print. And so if I put a space there, then it'll space them out. Like that. If I wanted a comma between them, great. I could put a comma, you know, like that. Then when I ran it, so like that. And for a single line like that, printing out a single piece of data, you wouldn't need it. But if you're printing out a series of values, it's pretty important. Something like this. For n in range 1 up to 21, get rid of that parentheses, print n comma end equals a space. If we didn't have that end equals space, we're pretty familiar with what it does. It just prints all the numbers in a sequence. Now it's going to print them all in one line. Right? And yeah, wrapped around at the end. What you'll usually want to do is then finally put a terminating print in it just to force it to go to the next line. Because if you didn't, the output point would still be left at the, wherever it was done printing. All right, so that's print end. Hopefully that's pretty clear. What was my mistake? In my examples, I put that. So if you actually tried to type it in and got a syntax error, thank you for texting me and asking me about it. All right, the last thing was on the summation loops. The question looks something like this. Int, no. Total is equal to 0, and then for x in range, up to 20. So since we're going up to 20, I have to go one past it. And then we had something like this. Total, I don't know why I didn't type this into idle so I could actually run it. But instead it had, fill me in. And then it had counter plus equals 1, something like that. And then fill me in to calculate average. And so we had two fill me ins here. What do we need to do with this one? I'll give you a hint. It's not total equals total plus x if we were getting input. I apologize. I need to add one more statement to it. Value is equal to input, whatever we're getting. Okay. If we just made it total equal total plus x or total plus equals x, we're just going to be adding 1, 2, 3, 4, 5, 6, 7. Not the test scores or the bowling scores or whatever that they want to calculate the average of. We demonstrate adding summations just because we can write it in a short loop. But usually the user is going to be entering the data. And so you don't want to do counter plus equals I or counter plus equals x in that case. You want to do counter plus equals value. And yeah, if you're typing this in, you're going to have to convert the input to a float or to an int before it actually works. And then down here, how do you calculate average? I think that if I just asked you to type it in without even giving you any examples, you would have done better than what happened. How do you calculate the average? Yeah, it's total divided by counter. I got a lot of answers that were counter divided by total. And that's not right. If you add 100 plus 100 plus 100, you have a total of 300 points in the class and 3 test scores. You don't want to divide 100 into 3 and find out you have an average of, 0.003, whatever. Instead, you want to get the total and divide it by the number of elements. So if you take the quiz again, I put a comment, on your answers there to indicate, if I didn't, it's here as big as life right now. Okay, so that was the stuff over question 4. Pretty much everybody got almost every question on quiz 5 fine. So I'm not going to even go over any of that unless you have any questions. Alrighty, so since we can do the review in about the last 15 minutes or so, I do want to hit another topic. This one's not really properly going to be on the exam. I don't believe in throwing stuff on you on the last day that's going to be on the exam coming up in 2 days. But I think it's useful stuff. And it reinforces some stuff that we've already talked about, which is the binary to hexadecimal. We did that, right? We did binary, and then taking a binary value and converting it to a hex value. Is that sounding?
We did that fundamentally.
Then we'll skip that portion of it. We'll loop back to it. There are no questions over it on the exam. But what we're going to talk about is data compression. Kind of slightly off topic of what we're doing here, but you could write your own program to do data compression. Right now there are, lots and lots of data formats for compression. There are zip files, there are RAR files. Can anybody name any others? Those are by far the two most common anymore.
Those are the ones that I've always used.
Yep, those are the ones that you've used. On the Mac, there used to be StuffIt and CIT files and stuff like that, but nowadays everybody uses zip, and everybody uses RAR. Yeah, 70 from 7-zip. There are other compression algorithms used, though. There's one used inside of MP3s, because if you had an uncompressed music file, it would take, megabytes upon megabytes, but instead they squeeze it down. So there's the MP3 comboning, right, lame. There's the MP3 encoding algorithms. There's another one for images. Your cell phones nowadays take, like 4,000 by 300,000 images. That's too large to store uncompressed. So they run the JPEG compression algorithm on them to shrink them down largely. Now the problem with JPEG is that it's what's known as a lossy algorithm. Lossy meaning that it loses some of the information, and the more compressed it is, the more information it loses. The same is true of the MP3 files. You know, you can dial it down to like 128 kbits, and it still sounds pretty good, but if you dial it down any further than that, and if you buy anything from Amazon or iTunes or Google, it's encoded like in 256 or higher so that it sounds good. We're going to talk about a lossless compression algorithm. Known as run length encoding. So if you check your contents, in October 3 notes, you'll see run length encoding. I did start yawn recorder, did I not? Good. Alrighty. So although what I'm going to demonstrate run length encoding with is an image, you could apply it to any form of data where you had a stream of numbers coming at you. So say we had this image, and we wanted to save it in a format a little bit more compressed than just saving it as a series of bits. What you can do is, for my fundamental students, they'll recognize this. You could say, okay, all these black squares are going to be zeros, and all these white squares are going to be ones, and you could save them as a series of hexadecimal characters. But we're not going to talk about that now. Here we go. Let's pretend that every black square is a 0, every white square is a 1, and if you look, that kind of matches. I tried to make it match exactly. I may have messed it up. Like that. So we're going to use run length encoding, or at least we're going to talk about it. Here's our data. There are a lot of redundancies in this data. There's an entire row here of blacks, of zeros. So if you wrote out to your file 12 zeros in a row, if you could write out something shorter that said, oh, by the way, I have 12 zeros in a row, that would help you a lot. This line's got a block of 4 zeros, followed by a block of 2 ones, followed by a block, of some extra zeros. So if we wrote down that the entire top, all 12 of these are zeros, and then that we have 4 more zeros, 2 more ones, and then 6 more zeros. If we did that right, it would wind up taking less space than what we see here. And by less space, I mean, smaller file size. And run length encoding is used out in the wild. It's used for the bitmap format, which you may have heard of, .bmp, and it's also part of the JPEG photographic compression. So what we do, we regroup regions of pixels. Should significantly reduce the size of our encoded data. So it's called run length encoding because you're keeping track of how many pieces of data are the same, the run length. So if this is our file, the top row has got 10 zeros. The next line has got 4 zeros, 2 ones, and 6 zeros, if I got it right. The third line, how many zeros? 3 zeros, 4 ones, 5 zeros, and so on. So if we were going to write this down in a format like that, we could do so. I got 10 zeros. I got 4 zeros, 2 ones, and 6 zeros. And on the third line, I had 3 zeros. I had how many ones?
Shouldn't that top one be 12?
That should be 12, yeah. My mistake. And so all of my slides are off because they all said 10, didn't they?
Well, the original image was a 10 by 10.
You're right. The original image was 10 by 10, and then I went back and I changed it to be 12 by, so that if we were going to do the conversion to bytes, we would need them to have to be a number divisible by 4. But we're not going to do that, so I just kind of messed myself up there. what I did is I padded it out with a couple extra zeros on the end to set it up for the next thing that we were going to do that we're not. So as we're going along, we had 3 zeros, we had 4 1s, and we had 5 more zeros. And we could do that all the way down the line. I'm not going to really do it. So it doesn't look like a huge savings in this example, but this is a very, very small image. Most images are far larger. You take a screenshot, then at the bare minimum, it's probably 1024 by 768 pixels.
4K screenshot.
Yeah. All y'all with your Surfaces or whatever, your Retina displays have, huge things now. So, and if they get saved as a BMP, which you probably don't do, maybe. Anyways, then, so your day, let's take a look at something slightly more appropriate. Here we go. Somebody's powered up Microsoft Paint or something like that and painted that. You can see that the pixels are very small, so we have vast areas of white, vast areas of orange. And so if you could say, okay, I have 100 pixels of white, and then I have 300 more pixels of white, like that, you'd just be writing out 100 white, and then the black, and then 300 whites, and you saved all of that space in your file. So that is a form of compression. Why is it called compression? Because you're taking the data and you're juggling it around so that it'll fit in a smaller file. And hopefully that file can be opened back up and read, expanded like you do with zip files. And you can see the same thing. Now, compression algorithms that you use for files on your computer, like RARs and zips and 7S's and stuff like that, had better be lossless. You'd be really annoyed if you saved your thesis paper and then when you loaded it back up, lots of data was missing from it because it was a lossy algorithm. JPEG is a different algorithm. It does use RLE for some of its stuff, but the reason that wouldn't work for photos is look how many different colors there are. It might be that encoding it as RLE would make a larger file than what your original input was, or at least you wouldn't get very much savings. Also, a problem with the BMP format is it assumes only 256 different colors are going to be in it, which is a pretty strong limitation. They've upped that to using PNG instead of BMP. It's a newer file format, although it's old now. Everybody uses it, which can display the full gamut of colors. So let's write a program that does run length encoding. And I did write it. Let me take a picture of it and then hide it again so that you aren't seeing it. Alrighty. Don't look. Don't look. Alrighty. Okay. So what do we want to do? I'm going to scroll down here and we're going to start over. And this also applies to my comment, my point on commenting, which is don't turn in programs without any comments. Pretty much every time I've started a program up here, I've demoed typing a student name and a date. And if you turn me in without even those, it's like, what are you doing? But more importantly, actually, than that, is documenting the parts of your program. And what do I mean by that? If you break it up into chapters, so to speak, or paragraphs, you'll see stuff like this. Declare variables. You might describe each variable as you declare it. And then you might see get input. Then you might see process input. So getting input might just be 1 line, might be 10 lines, might be 20 lines. But at least as you look at it, you'll have a comment describing what the next section of code does. And it also kind of serves as an outline, like when you're writing an English paper. You have 5 paragraphs that you're going to write. And so you just come up with a 1-sentence description of each paragraph, and then later you go and fill it in. Now this one, I'm not sure how many variables I'm actually going to declare beforehand, so that's not a section that I really need for this particular case. But I would put some information here. Example of RLE, run length encoding. So our input's just going to be as easy as doing this. S is equal to input. Give me some data to compress. And our data is just going to be typewritten characters, right? We're not going to load a picture into it. We're just going to type in a whole bunch of A's and B's and 1s or whatever. So I'm calling it S, but maybe we should call it data. So now what we want to do is, how are we going to search this? Let's say, don't type this because I would just erase it in a minute. Don't type this. But say we had this. Please don't type it. I'm going to delete it. Say we had this. How do we know how many characters are the same? What you got to do is you got to store that one and then start counting. Yeah. I have an A. Is the next one an A? Yeah, increment my counter. Is the next one also an A? Yep. Is the next one also an A? Yep. Is the next one an A? Nope. Okay, reset our counter and set this to be the new character that we're going to be searching for. So we need a couple of things. We need a character to match, like we're going to start off counting A, and then we're going to keep going. And we need a counter. So since we're talking about RLE, I think I'm going to call this R match. Could call it anything. And I'm going to set it equal to the first character of the string, because I'm going to be checking for A's first. And then I'm going to do R count. And it's going to start off as 0. We don't know how many numbers in a row we have. Actually, we could probably start it off at 1, because we know that we have at least one A, because we started there. So I'm going to reset our count to 1. Now we need a loop. We could skip the first one. I suppose if we left it at 0, we wouldn't have to skip the first one. All right, let's set it to 0 then. And then we need a for loop to iterate through all those. There are different kinds of for loops. There's a for, don't type this, for x in range, right? We could use for x in range, but is there a better kind of for loop for this particular kind of thing where we're stepping through a string looking at item by item? Yeah, that would work. That's a range based, but we can also use for value in string. So something like this. For character in our data, for every character in our data, let's make a comment that there's effectively two kinds of for loops. There's for x in range, and then there's for value in list. Those are really our two kinds of loops. Other languages call this a for each loop. For each value in the list. And that's what we're going to do here, because all we care about are the values. So if our character equals our R match, which right now is set equal to A. Oh, I said I was going to delete that line. Get rid of that. Then great. Increment our counter. R count plus equals 1. If not, we've got a problem. I mean, it's not a problem. It's just a change of state, right? We had all those A's in a row. Don't type that. And now we're going to process some B's. So now that we've hit this switch point, we need to do a few things. We could print out the number of A's we found, print out what character we were looking for, and then reset our counters.
For your first iteration, R count has to start at 1. Because when you do data 0, you already have A.
I thought that,
'Cause if you
But-
do a character equal to our match,
But it's actually going to start at the first character. I thought that too, and I could be wrong. You may be right. The first time I wrote it, I started searching at the second character. But if I'm starting at the first character, I'm going to check to see if the first character is equal to itself. And yeah, it always will be, but that'll add 1 to our counter. Does that make sense?
yeah,
I know.
okay.
I should improve it. But I wanted to avoid using a range statement, although that's how I wrote it up there. And maybe I should have. My first inclination was to do it the way you're suggesting. Start the counter off at 1 and then count, skipping the first character. Okay, so if that's not right, we need to reset a couple of things, and we need to print some stuff out. Or we would add it to a list, or we would write it to a file or whatever. So let's do this. Print %D is going to be our match counter. And then we're going to do %S to print out the string that we just matched, the letter. And then since we're doing those percents, we need to fill them in with the right placeholders. So we're going to print out R count and R match. And then I'm going to take advantage of the E and D equals space, like that. So you see what we're doing? I'm printing out the count, like I have 3. I'm printing out what we just matched. I had 3 A's in a row. And no, I don't want you to go to the next line. I want all of our output on one line. All right, at this point, we need to reset our counter, but we do need to set it equal to 1. I wish I'd done it the other way. Should have done it your way. And then I need to set the match equal to our current character. Why am I setting it to 1? Because we know we already have that character. R match, thank you. All right, that should be the end of our loop. But when we get to the end, we need to print out our final counter and our final match, because we may never have hit this. What if it was all A's, beginning to end? We would never get to this state. So our last thing we want to do is to print this stuff out again. I'm just going to copy that, paste it like that, indent it, and I'm going to take off our end parameter like that. Don't need that because I want it to go to the next line now. We're done printings. Okay, I had some garbage up here I need to get rid of. I had that up there. Okay, so if I was going to give, like section headers, we got our input, and then let's do initialize counters. RLE counters. I don't know if that's quite the right term, but these are our loop variables. These are the pieces of data that matter very much to us. How many characters we have found, and what that character currently is. All right, it might actually work, but unfortunately I had this stuff up here. Let me comment that out. If you want to comment out a whole bunch of code, if you're using idle, I believe you can highlight it all and then just do format, comment out region. But another quickie way is to type 3 quotes at the beginning of the section, 3 quotes at the end of the section, and that turns the entire thing into comments. Makes it a different color in idle, but it's still a comment. It could have made them red just as easily as anything else. That would have been my preference. Let's run it. See if my system worked. We may have to revise it. Give me some data to compress. Okay, I'm going to type in 4 A's, 3 B's, 1 C, and 2 D's. 4 A's, 1, 2, 3, 4. 3 B's, 1, 2, 3. 1 C, and 2 D's. Because I'm hoping our output will say 4A, 3B, 1 C, 2 D's. All right. It did. I'm somewhat relieved. So does this look like it's really compressed? Well, when you store this stuff out, you're going to be saving these numbers in a format that's better than just displaying an ASCII character like that. And you would be leaving off these colons, and you would be leaving off the spaces between them. But again, the shorter the data, the less compression you get out of it. Worst case is if you don't have any repeats at all, in which case your run line encoding is going to actually be larger than... One thing that compression algorithms do, though, is they look for better ones than RLE, is they look for combinations that are larger than just one. And zip is really good at that. You know, if you have the word "the" in your sentence a whole bunch, I mean in your data a whole bunch, you could just choose that. And then you could say, okay, you know, I have 30 of these in a row. Or whatever. You know, larger chunks of data than just one character, just one value. So if you write a text file that has the same paragraph, cut and pasted, you know, 10,000 times, zip is going to be able to squeeze the heck out of it. It's going to recognize that that stuff is just the same, and then it's just repeated 10,000 times.
It's going to put the paragraph in times 10,000.
Yeah, exactly. It's going to pretty much do that.
There's another position, you know, for instance, if you say the word "the," doesn't know to what position it goes when it's decompressing.
The compression algorithms are very carefully written. That's all I can say. But they have to keep track. They build a table. PKZip builds a table of matching patterns in it before it even starts writing the file out. And once it's got a big table of matching patterns, it encodes that table as the first thing in the file, and then it actually runs through the file. And every time it finds a match, it just writes out the number of that pattern. Alrighty. That may be enough about run length encoding. Just kind of wanted to broach that because that's more interesting than just writing, you know, if x is equal to 3, print blue, you know. Kind of a real world kind of thing you would do. And this stuff, I think the first, according to Wikipedia anyways, the first application for it was to compress television broadcasts. You know, when they were very first beginning to send stuff by satellite and stuff like that, you wanted to minimize the amount of data you were bouncing off that. And so you could encode the colors of each pixel on your TV set using RLE. Now, we already talked about that the more colors in the image, the less effective that works, but sometimes the screen is entirely black, you know, or it's got huge washes of color, you know, that are the same or stuff like that. Nowadays, they use far better compression algorithms to encode your DVD and stuff like that. Or your digital cable, you know, when it first tunes in and it's really blurry and it's got big blocks everywhere, and then finally it starts filling in everything. It's running, you know, a compression algorithm there that's designed so that you could pick up on it at any time. Something like the zip format where it builds a table up at the very beginning wouldn't work for streaming video because you need to be able to tune in at it on any point and have it fill in. But that fill-in process can take a little while, and that's why your image may look really lousy when you first tune into a different digital signal, or you know, you slide your slider over to the middle of a movie, you know, then it may look lousy for a moment. I forget which service it was. I think it was Amazon. That would always annoy me because the first 30 seconds of watching the video would look lousy because I hadn't figured out how to uncompress it yet. And I'm thinking, I paid for this video. You ought to be able to display the first 30 seconds of it. And maybe it was just because I was watching it on an iPad or something and it would have worked better on the PC or something else. Alrighty. That's about enough of that. Looks like we had two programs here unless you tacked this on to that September 26th one. Excuse me. Where'd I get September? Did I really call the other one September? Did I have September on the brain? September 3? Really? Alrighty. I was nervous. Had my superior watching me when that was happening. Alrighty, so you could just take the RLE, copy and paste it into here. or you can just upload 2 programs. Let's go ahead and make a Dropbox for it. And we'll hit that other topic after the exam when we start talking about converting bits into what are known as hexadecimal values. For those who did not take my particular fundamentals class, it will be new material probably. So when I ran it, and I said it doesn't look like much compression. If I ran it again and I typed in you know, 1,000 A's before I typed in another piece of data, and then 1,000 more A's. There, that looks pretty nice. Good example of compression. The more duplicate data in your data stream, the better compression algorithms will work. There are, I won't call them audio snobs, they're the audiophiles, audio fanatics, who say that MP3 sounds lousy no matter what. And so some sites sell what are known as lossless audio files. And those are files that the MP3 algorithm hasn't been run on, because MP3 does work by losing a little bit of data. It's data that your ears supposedly can't hear, but they say that they can. And so they buy these files that are 10 times the size of the MP3 files, and then they don't play it on their iPods, but there are devices that are capable of playing them, or they listen to them on their desktop computer. Where was I going with that? Oh yeah, Dropbox. I'm still typing September. It's like when you keep writing 2016 all the way through January, even though it's the new year. Yeah, whatever. All right, the review of you've already done the reviews. The quizzes are your best reviews for them. But looking at the exam, I realized that there was a style of question that I did not ask on the quiz. So we're going to go ahead and cover it now. I think I did this in class, but maybe I didn't. And it's about function definitions. If I write a function called a, that what it does is it prints a, and then I write another function called b that prints b, and then I write a function called c which calls a and then calls b and then calls a again, and then at the very bottom I call c. What is it going to print?
It's going to print the 3 A's, the 3 B's, and the 3 A's.
Yeah, you see what's happening. It looks for the first unindented line of code. Woohoo, it jumps here. Woohoo, it jumps up here. It prints AAA. This returns, comes back down here. Oh, we invoke B. Comes up here, prints BBB. Comes back. Returns out of there. Now we're here, and it's going to print out AAA again. And there could be, different combinations of that. Like, what if I threw in an extra B down here? In that case, after it did all this rigmarole, we have one final call to B, so it's going to print BBB again. Another thing to remember is the upper limit and the lower limit of range statements. If you want to print the numbers 10 through 30, your range had better look like this, 1031. If you do 1030, it's wrong because it'd stop at 29. And I'm really apologetic, but you have to go one past the point where you want it to stop. Just accept it. I wouldn't have written it like that. But the way what this means is x is equal to 10 while x is less than 31. You see that less than? It'll never hit 31. It'll stop at 30. So that's what that means, is that you give it a starting point, it initializes it, and then it keeps going while that value is less than 31. So what if you had something like this? Define Joe, which takes a value, and Joe returns 10 times x. And then you define another function which returns 2 times Joe x. And so then down here at the bottom, you say number is equal to 100. And then Bob, print Bob number. Like that. What is it going to print? Well, skips that. Comes down to here. Okay, my number is 100. Invoke Bob. It jumps up here, passing in 100 into the parameter. And then it goes, okay, I'm going to call Joe with that value. So we still keep that number up here. And so it returns 10 times whatever was passed in, which is 100. So that's 1,000. So it returns 1,000. Now we have 1,000 here, which gets multiplied by 2 to make it 2,000. And that gets returned here so that we can print it out. I'm going to write one or two more like that, and I want you all to figure them out. What is hiss? And yeah, you could take the time to type it in and run it. That's going to take you a minute or more, where maybe you can just process it. Just go ahead and stare at it for a minute, figure out what it is, and then I'll ask. I think I heard somebody say it.
22. Yep.
I'm thinking it's going to be 22. Am I right? How many people got 22? Lots of y'all. Okay. So for those who just didn't wave your hand, what are we going to do? We're calling hiss. X is now equal to 10, right? And then so we return, we pass this into here, x is 10, it returns 1 plus x. So this boo here is equal to 11. Plus, pass in boo called with 10 again. Returns 1 plus 10 is 11. So 11 plus 11 would be 22. Sometimes I'm a jerk and turn the recording off during the preview, but since half the class or more is taking it remotely, I can't get away with that. I will probably do that when we actually go over the exam once it's done, though. Maybe not, I'll think about that. Alright, write a function that returns a this. Write a function that accepts a parameter. Write a function named cube. I'm going to change that. Alright, we're skipping the part about lists. Reloaded, come on. Come on. Get to the next quiz. Alrighty, here's kind of a generic question. I don't remember it being on the quizzes. If you have that, what does something one need to be? What kind of expression is it? It's a true-false. It has to be something that evaluates the true-false. That means it could be something like, A is less than 10. Worst, not the worst case, but, true. That certainly is a true-false value. Or it could just be a variable while repeat. Something like that. Same's true of if statements, The thing inside the parentheses is a Boolean condition. So it can take a Boolean expression or variable or value. The word true is a value, not a variable. Pay attention to less than versus less than or equal to. X is equal to 1 while X is less than or equal to 10. Print X. How many times is it going to print? Well, just count it out. 1, 2, 3, 4, 5, 6, 7, 8, 9. Is it going to stop there or is it going to go ahead and include 10? It's going to include 10, so I'm going to put a space there. But so that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 values. I'm always going to make these small enough you could actually count them. I'm not going to start it off at 400,000 and make it go up to 1.2 billion or something like that. Just know that you either are stopping before the value here or at the value there. And if you do it less than, it wouldn't have printed that 10, so it would have only printed 9 values. Just count them out. Kind of like counting on your fingers. If it's not immediately obvious, then you'll get it right. All right, we all know what a sentinel value is now.
Basically, the difference between it and a break is just, it does the same thing as a break, but you're telling it that you want to break out.
Right. It tells you that you want to break out, but it's not a break value. It's a break. You use a break statement to implement it, perhaps, but it's a sentinel value. Sentinel value is a piece of data that means something different than the rest of the data. Terminates the loop. One more thing on the questions about where it had, fix me 1, fix me 2, and fix me 3. Part of the code was to make it find a minimum and a maximum. And so, part of it looked like this. Value is equal to input whatever, int version of the input or whatever. We had to get our input. And then while the value is not equal to -1, how do we keep track of our minimum or our maximum? First thing you have to do is to initialize your minimum or your maximum. You can do it more than one way. The last time I did it another way, I set it equal to none, and then I did some rigmarole there. But here's what we're going to do. Just in this case, we need a counter or whatever, but there's going to be a line of code, fix me, and then there's going to be another one that gets a new value. Value is equal to the integer version of input. What needs to go and fix me? Well, we're going to be checking the max value. So if max is something, and then something here underneath it, do we want to check to see if max is greater than the current value? The long pause means that no, we don't want to check to see if it's greater than the current value. A lot of people pick that. We want to see if it's less than the current value. Why? So that because if you're smaller than what you're looking at, that's our new max, right? Like that. So that would have been the correct answer on that question. And it's probably going to come up again on the exam, so that's why I mention it. And I may not have given you a super duper clear explanation in the feedback. I may have just said check the logic. But that's it. And I had a question from somebody asking how to do the bit on their homework, where you were adding up all the values and checking to see if they were even, checking to find the max and the minimum and all that stuff. It's the same kind of deal. Yeah, we did a more complicated version of it where we set max equal to none. And here this required a priming read to write it out like that. You don't have to use a priming read, but let's go for it. We need to declare a counter that says how many values we've read in. And we need an initial value. That's not bad. Or we can just use a while true. I'm just going to use a while true. I find that to be the easiest way. And then we get our input. Value is equal to the integer version of the input of give me a number. Once you have that, you need to start incrementing your counters. This isn't your only counter. You need to know what the max is. We've got that. You're also going to need to know what the min is. I'm going to do the same thing, but I'm not going to show how to do it. And then the number of evens, which right now is 0. Okay, so then you just start checking. How do you see if something is even? Even means you divide it by 2 and you don't get a remainder. So what operator do you use? You use modulus. So if the value, wait, first of all, let's just check to see if it's equal to -1. Give me number or -1 to quit. That'll be the first thing we do. If value is equal to -1, break. Right? All right, but now past this point, we have good data. So we can increment our counter. We know that's right. We're going to increment evens if the condition is true. If the value modulus 2 is equal to 0, that means it's an even number. And then lastly, we're just going to do that thing that we did up there. If max is equal to none, or max is less than the current value, max now gets set to our current value. Like that. And you do the same for min, except you change the logic. If min is greater than the value.
Yep.
I think that's right.
Yeah.
Right.
Greater than, yeah.
No, that's wrong.
The max
Is it?
if the max is less than the value, then the value is the max, and if the minimum is greater than the
Right, if the minimum is greater than the value. Okay, so that is correct. Alrighty, so that's your basic structure. So if by chance you haven't done that homework yet, that's pretty much most of the answer right there. All right, back to the review. And a lot of these questions are from the quiz, so I'm just trying to remember which ones are and which ones aren't. All right, part of it's going to be stuff like x is equal to 2 times 3 plus 4 to the power of 5, right? That kind of thing. You know how to figure that out. Rules of PEMDAS.
Do we have any questions around
Thousands. Let me look. Probably about 50 or 60. More PEMDAS. All right. Given an equation like this, 4 over 3 pi r cubed, express that as a formula. Right? We did something like that with a circle, I think. 4 pi r squared, I think. Same idea. Just express it as a formula. And y'all are really good at that. You just know that just because two things are side by side on an equation doesn't mean you can type them in that way on a computer. You have to type the multiplication between them. Remember the difference between division and floor division. If you do A is equal to 3 divided by 2 and you do B is equal to 3 / 2, which one of those is equal to 1 and which one of those is equal to 1.5? One of them is equal to 1. Which one? Yeah. B is equal to 1 because / means divide and round down. A is equal to 1.5. Then you go and take Java and C++ and the rules change and you get frustrated. All right. Know what an integer, a float, and a string is. If it's got quotes around it, it's a string. That's just really what it boils down to. Doesn't matter if it looks like a number. A is equal to 3.0. Still a string. Looks like a number, but it's still a string. A is equal to 3 plus 4. What is that going to... What's the end result? 7? No, it's 34. Right, because it's two strings being concatenated together. There are functions called min and max. I just don't recall talking about them that much in class, but I see them on the exam kind of implying that they're talked about in the book. So if you print the max of 10 and 20, it's going to print 20, right? And then if you print the min of 10 and 20, it's going to print 10. Flowcharting questions I'm going to delete. How about some of the character functions? String is equal to Joe Bob. If B in S print 1. Is it going to print 1 or is it going to print nothing? Well, is there a lowercase b in S? Yes, there is a lowercase b in S, so it's going to print 1. If we did something like this, if capital O in S, print 1, print 2, whatever, is it going to print a 2? Well, there are O's, but there are no capital O's, so it would not print 2. You know what is upper, is alnum, what those do? X is equal to 1, 2, 3A. B is equal to is X dot is alnum. Is B equal to true or false? What does alnum mean? Alphanumeric. All the letters and numbers. Is this made out of all letters and numbers? Yeah, so that's a true. X is equal to AAA. B is equal to X dot is upper. Is that true or false? Is it all uppercase? Yep, so that's true. How about B is equal to X dot is lower? Obviously it's not true. That would be false. S is equal to Joe Bob. If S dot ends with OB, is that true or false? It ends in OB, so yeah, that's true. Print S0. What's it going to print? That's index position 0 of this string, so what's it going to print? It's going to print J. Print S1, pretty easy, it's just going to be the next one over. And O. Print S negative 1. Negative means it goes to the end and starts counting backwards, so it's going to be a B. I think I'm going to delete the questions about turtles. That wasn't the real point of this. Maybe just one. If you have a statement included in another decision statement, like a while inside of a while or an if inside of an if, what is that called? Those are nested statements. All right, you want to take 2 to the power of 3. 2 to the power of 3, that's one way to do it. Are there any others? The answer is yeah. There's power 2 to the power of 3. And yeah, you could just do 2 times 2 times 2. 2 times 2 times 2 would also do it. And then oddly, there's math.pow, 2 to the power of 3. And right offhand, I don't recall why there's a different power function than math.pow. Supposedly math.pow is most properly used with floating point data, not ints. I don't know. Why? Be able to write something like if x is less than 3 and x is not equal to y. Just know how to do that. That one's pretty easy, right? If x less than 3 and x not equal, exclamation mark equal, y. More complicated, but not much. If x is between the values of 10 and 20 inclusive, meaning that both sides, both 10 and 20 are true. How do you do that? If, where would I start? I could start with the 10 or the 20. Which do you like better? I'd say 10. So it ought to be if x, I'm checking to see if x is between 10 and 20. So if x, y'all are going to make me do it, aren't you? If x is greater than equal to 10, do I want an or an and? And x is less than or equal to 20. That's how you would do that one. So many flowcharting questions. Remember that if we're talking about pseudocode, set A equal to B plus C, or B added to C, and then I asked you to write that in Python, you just do A is equal to B plus C. The word set is pseudocode, meaning it's not actually part of a programming language. It's just English helped describe it. All right, we're done. There's going to be one little flow chart that I want you to turn into code. And it's going to be something like ask the user for this information, convert the information to this kind of data, like a float or an int. If that data is something, if it's greater than something or less than something, print something. Else, if data is something, then do something else. Finally, print a last message. Something like that. Something we've done so often it'll be really easy to do. All right, gang. I think we're about done. The Dropbox is there and everybody got it uploaded, right? Any questions over the quizzes? We have a little bit of time before the next class. Otherwise, we're done.
How long is the quiz?
Pardon me?
How long will it take?
Um,
Is it 1 hour?
Some people like walk out of these things in 20 minutes. Some people use up the entire hour and 15 minutes. I try to make them about 50 minutes long
Is it about
because I don't want people to sweat and wish that they had more than an hour and 15 or hour and 20 minutes. So
how many questions are there?
about 50 or so.
50?
Yeah, one a minute. Lots of them are already been asked in the quizzes, so you'll probably be able to rocket through those pretty quickly. Alrighty, people usually do pretty well on it. Yes.
I was just having trouble with my RLE.
Oh, you were doing it with a counter.
Yeah, just bringing it out. I thought I copied it exactly.
Well, I'll bring it back up. I'm not spotting it. If CH is equal to match, great, put it in our counter. If it's not, set the counter to 1. Match is equal to CH. I'm not seeing it at all. Run it one more time, please. Type in A. Oh, R match. So when I coded it, my first effort at it, I set matching equal to 0, and I started our range at 1 rather than 0. So.